Okay, so this is a electromagnetism question that is on an electron moving into a magnetic field. So pretty standard. So it shows the path of an electron traveling at a constant speed. Okay, constant speed before it enters a field. Okay. So the flux density is also given. So if the velocity of electron is perpendicular to the direction of B field, calculate the EM force on the electron in the field. So basically, we are going to just use the formula F equals to BQV sine theta. And they already tell you that theta is going to be 90 degrees, okay, perpendicular. So this is going to be 1. So basically, the answer for part A is just going to be F equals to BQV sine 90 degrees. Now, B is 0.01. Q, which is the charge of the electron, this electron, it should be given the list of constants, 1.60 times 10 to the power of minus 19 coulombs. Okay, so we have 0.01 times 1.6 times 10 power minus 19. Velocity is 3 times 10 power 6. Okay, let me just key into the calculator. You will get a very small number of 4.8 times 10 to the power of minus 15 newtons, okay, which is pretty small, but it is normal because this is just an electron, okay, and the electron, you must remember, the mass is in the order of 10 power minus 31 kg, so in a way it's actually much bigger than the mass. Okay, so now determine the radius of the circular path of the electron in the field. So part B is pretty straightforward. Okay, first step, we are going to say that the magnetic force, hmm, magnetic force provides the centripetal force. So magnetic force provides the centripetal force. Therefore, BQV must be equals to mv squared over r. Because it's perpendicular, so we just sine theta, sine 90 is 1. If it's not perpendicular, it will be a helical motion already. Okay, so this is just a circular motion. And when we rearrange, r equals to mv over bq. Okay, so you cannot just use this formula directly. You have to prove this. Okay, this step 1, step 2, step 3. And with this, we can use the mass of the electron. Okay, the mass of the electron is given by, in the list of constant, you will have 9.11 times 10 to the power of minus 31 kg. Okay, V 3 times 10 power 6 over B 0.01 and 1.60 times 10 power minus 19. Okay, so now I'll just again also press in the calculator. 9.11 times 10 power minus 31 times 3 times 10 power 6 over 0.01 times 1.6 times 10 to the power of minus 19. And I get 0.00171 meters. Okay, again, in exam, they might ask for cm or mm, so just take note. Okay, so next, on the figure, sketch the path of the electron after it emerges in the field. Okay, in the field and after it emerges. So this one, you'll need your Fleming's left-hand rule. Okay, take note, electron current and the conventional current is opposite direction. So conventional current is going to be leftwards. Okay, and B field into paper. So using your Fleming's left-hand rule, F, B, I is towards the left and B, you'll get a force that is downwards. So, okay, I'll just change a different color so that it's not so confusing. So in here, you should be drawing a circular path. Okay, so draw in one line. Try and draw in one line. Okay, draw a circular path. Okay, it's a bit hard for me here. Okay, let me just erase here. Okay, so we try and draw in a circular path, and the moment you exit, what they want to see is a straight line. Okay, oops. So they need a straight line the moment it exits to show that there's no more force. Okay, so inside is a curve, but outside is a straight line. So we just like that and then straight line. Okay, So this is your part C's answer. And part D, state and explain and whether any work is done on the electron. Now, take note that the magnetic force provides a centripetal force, okay? And centripetal force itself have zero work done because it is always perpendicular to the direction of velocity. So because of that, basically we just say work done, no work done. Okay. And then just add a little bit. Now this is because, let me just add in here. This is because the the magnetic force provides the centripetal force. Oh wait, the magnetic force which provides the centripetal force, right, is perpendicular to the velocity at all times. Hence, the work done is going to be 0. Okay, so yep, so that is the answer.